Okay. Yes. Again, this is the second problem. What we have here in the DC distributor, that is again we call this to be which is uniformly distributed. So it is uniformly loaded. So is loaded. Yeah, I should have included uniformly. Yes. So a two-wire DC distributor which is fed at one end, which is 500-meter long, is loaded uniformly with 0.4 ampere per meter. If the maximum permissible voltage drop is 10 volt, find the cross-sectional area of the distributor conductor, that is the distributor conductor, cross-sectional area of the distributor conductor. So take rho to be equal to 1.7 into 10 power minus 6 ohm centimeter. I repeat, so it is ohm centimeter. So what is to be found out is, let me draw a DC distributor here. I have A and B as a DC distributor. So this is the current entering the point A, that is the feeding point A. A is said to be the feeding point. And what is to be there is the permissible voltage drop across the length of the distributor is 10 volt. So this is the length and this is the maximum permissible voltage drop. So maximum permissible voltage drop is 10 volt. And what you need to find out? You need to find out the cross-sectional area of the DC distributor conductor. So it is not said as conductors, it is a conductor, one single conductor which is there. So it is not for total area, it is not like that. You need to find out only the cross-sectional area of the distributor which is being present there. So first one, let me write down. Length of the distributor is half a kilometer, that is 500 meter. It's a two-wire DC distributor. I is said to be 0.4 ampere per meter. Okay, so 0.4 ampere per meter. So how do you calculate I? So it is I into L. So that is 0.4 into 500. So 0.4 into 500, which is 200 amperes. So capital I is said to be 200 amperes that is being present there. So next one, what you need to do is you need to calculate the maximum voltage drop. So maximum voltage drop, it is already given. So that is 10 volt. So how you are going to find out is capital I into R divided by 2. So this is 10 volt which is there. So I is given as 200 amperes. So you need to find out what is R. So after finding out R, you can find out what is small r also. So 20 divided by 200. Okay, so I'm writing out directly. So R will be equal to, so 1 divided by 10. So capital R is equal to 0.1 ohm. So 0.1 ohm which is there. So R will be equal to R into L. So R by L will be equal to small r. So capital R is 0.1 divided by 500, that is equal to small r. So small r will be equal to yes. So small r will be equal to, that is if you take, so 0.1 divided by 500. So that is what it has been there. Okay. So you will be getting 0.2 into 10 power minus 3. Okay. So this is what you are going to get there. So this is small r. Let me write it properly. Yes. Okay. Yeah. So small r will be equal to 0.2 milli ohm. So 0.2 milli ohm, small m, that is milli. So area of cross section of the conductor. So it is r by 2 there. So that is what you are going to get there. So you are going to get 0.2, that is r by 2 is there. So this is r by 2, that is being getting as 0.2 milli ohm. So this is a correction. So this is r by 2 which is 0.2 milli ohm. Okay. So next what you are going to get is A is equal to rho L divided by r by 2. So you are going to get it as 1.7 centimeter squared at the end. So A, the area of cross section of the distributor conductor is 1.7 centimeter squared. So if you do it carefully in the calculator, you'll be able to find out what is R. If you are finding out R, so if you want to find out small r, okay, so small r can be found out per value of the conductor which is being there. So that's the way you can find out what is the area of cross section of the distributor conductor, which is 1.7 centimeter squared there. So this is one of the simplest problems what you can find out. So these are the important problems there. So we will stop here. So this is quite simple and you can get the result easily.